Modernage MCQs, Physics second year, Unit 13, Electromagnetism, Part 4. The current in a galvanometer is changed in the ratio of 3 to 5. What is the ratio of the twists produced in the suspension strip of coil? Option A 3 to 1, option B 1 to 5, option C 3 to 5, option D 5 to 3. The key is 3 to 5. Therefore, the correct option is C. Reason: the relation between the twist in the strip and current I is proportional to theta. Therefore, theta 1 divided by theta 2 is equal to I1 divided by I2, which is equal to 3 divided by 5. Therefore, theta 1 to theta 2 is equal to 3 to 5. Hence, the ratio of twist in the suspension strip is 3 to 5. A galvanometer of resistance Rg is converted into ammeter of resistance Ra. The resistance Ra is option A Ra greater than Rg, option B Ra greater than or equal to Rg, option C Ra less than Rg, option D Ra is equal to Rg. The key is Ra less than Rg. Therefore, the correct option is C. Reason: the galvanometer is a sensitive device. It gives full scale deflection for very small currents. For the measurement of large currents, it is converted into ammeter by using a shunt resistance parallel to the galvanometer to bypass large part of the current through it. The resistance of ammeter Ra is an equivalent resistance of the parallel combination of shunt resistance and galvanometer resistance. Therefore, Ra is equal to Rs, the shunt resistance, Rg, the galvanometer resistance, divided by Rs plus Rg. Hence, the resistance of ammeter is Ra less than Rg. A galvanometer of resistance Rg is converted into voltmeter of resistance Rb. The resistance Rb is option A Rb greater than Rg, option B Rb greater than or equal to Rg, option C Rb is less than Rg, option D Rb is equal to Rg. The key is Rb greater than Rg. Therefore, the correct option is A. The reason: the galvanometer is a sensitive device. It gives full-scale deflection for very small voltages. For the measurements of large voltages, it is converted into voltmeter by using a high resistance in series with the galvanometer to allow current Ig for full-scale deflection. The resistance Rb is an equivalent resistance of the series combination of a high resistance and galvanometer resistance, which is Rb is equal to Rh plus Rg. Hence, the resistance of voltmeter is Rb greater than Rg. The battery of Abbottabad supplies current for measurement of option A current, option B voltage, option C resistance, option D power. The key is resistance. Therefore, the correct option is C. Reason: an ammeter draws current from the circuit for the measurements of current and voltage. There is no current source in resistor itself. Therefore, ammeter supplies current to the resistor from a battery installed in it for the measurement of resistance. Hence, the battery of ammeter supplies current for the measurement of resistance. A 1.5 volt battery of ammeter supplies current 1 milliampere to a resistor. The resistance measured by ammeter is Option A 1.5 ohms, option B 1.5 kilo ohms, option C 1.5 mega ohms, option C D 1.5 giga ohms. The key is 1.5 kilo ohms. The correct option is B. Reason: the Ohm's law V is equal to IR gives the resistance measured by ammeter as R is equal to V divided by I, R is equal to 1.5 divided by 10 power minus 3 R is equal to 1.5 into 10 power 3 ohms. R we can write R is equal to 1.5 kilo ohms. Hence, the resistance measured by ammeter is 1.5 kilo ohms. A wire of length 2 centimeter lying perpendicular to magnetic field of 5 Tesla is experiencing a force of 12 Newton. The current in the wire is option A 20 ampere, option B 12 ampere, option C 5.0 ampere, option D 1.2 ampere. The key is 20 ampere. Therefore, the correct option is A. Reason: putting values of force F, magnetic induction B, the length L, and theta in the force formula, F is equal to BI L sine theta. We have 12 is equal to 5 into I into 0.12 into sine 90 or 0.6 I is equal to 12 because sine 90 is equal to 1. Therefore, I is equal to 20 ampere. Hence, the current in the wire is 20 ampere. A source of 9 volt with internal resistance 3 ohms is connected parallel to a galvanometer of resistance of 33 ohms. What will be the current in the galvanometer? Option A 300 milliamperes, option B 250 milliamperes, option C 200 milliamperes, option D 150 milliampere. The key is 250 milliamperes. Therefore, the correct option is B. Reason: from expression V is equal to I into small r plus capital R, where small r is the internal resistance of the source. Ri is equal to V divided by R plus R. The current through the galvanometer of resistance Rg is Ig is equal to V divided by small r plus Rg. Thus Ig is equal to 9 divided by 3 plus 33, or Ig is equal to 1 by 4, or Ig is equal to 0.25 ampere. Hence, the current in galvanometer is 250 milliamperes. A solenoid has N in length L. The magnetic flux density inside the solenoid produced by current I will be option A mu naught NIL, option B mu naught NL divided by I, option C mu naught NI divided by L, option D NIL divided by mu naught. The key is mu naught NI divided by L. Therefore, the correct option is C. Reason: the magnetic flux density inside the solenoid is B is equal to mu naught and I R. B is equal to mu naught into N divided by L into I. Therefore, B is equal to mu naught and I divided by L, because small n is equal to capital N divided by L. Hence, magnetic flux density inside the solenoid is mu naught and I divided by L. The force acting on a cylindrical conductor of length 1 meter carrying a current of 1 ampere lying normal to a magnetic field is called option A permeability of conductor, option B permittivity of medium, option C magnetic flux only, option D magnetic flux density. The Key is magnetic flux density. Therefore, the correct option is D. Reason. From F is equal to BIL sine theta, we have the force on conductor. F is equal to B into 1 into 1 into sine 90, or F is equal to B, because sine 90 is equal to 1. Therefore, the force on a cylindrical conductor of length 1 meter carrying a current of 1 ampere lying normal to a magnetic field is the definition of magnetic flux density. Hence, the force is called magnetic flux density.